All right, welcome back. Today we are diving into some really cool and kind of invisible science. I'm talking about the secret that literally holds our modern world together. It's the reason the logo on your water bottle doesn't just flake off, or why the paint on a car bumper looks perfect for years and years. So let's get right into it.
So let me ask you this. Have you ever tried to spray paint, say, a plastic chair? You do a great job, it looks fantastic, and then a few months later, it's just peeling and flaking off. It's a disaster. But then you look at the logo on your shampoo bottle, and that thing is practically indestructible, right? It's the same basic stuff, plastic, but the results couldn't be more different. So what's the deal? What's the secret sauce here?
Okay, so the whole problem really starts at the molecular level. You've got these super common plastics, things like polyethylene and polypropylene, that have what engineers call low-energy surfaces. Now, what does that mean? Just think of a nonstick frying pan. Things just slide right off, right? These plastics are basically like that. They're designed to repel stuff, which is great for keeping your food fresh, but it's a total nightmare when you actually want something to stick to them permanently. So how in the world do manufacturers get around this super tricky problem? Well, the solution is, honestly, it's as brilliant as it is surprising. They fight it with fire. Yeah, you heard me right. A very, very precise and controlled touch of flame. This whole process is called flame surface treatment. And I gotta stress the most important part here, precisely controlled. We're not just, taking a blowtorch to a plastic bottle. No way. This is way more sophisticated. Think of it like a carefully engineered flame is performing microscopic surgery on the surface. It's actually changing the chemistry of the plastic right on the top layer to make it want to grab onto inks and glues. So how does this actually work? Well, it happens in a flash. Literally, you start with that slippery, low-energy plastic surface we talked about. Then this super controlled flame just zips across the surface in milliseconds. And that quick burst of heat doesn't melt it. Instead, it kicks off this neat chemical reaction. It basically creates all these tiny microscopic chemical hooks all over the surface. A good way to think about it is like scuffing up a really smooth wall with sandpaper before you paint it. You're giving the paint something to grab onto. And that's exactly what this does. It transforms the surface into a high-energy one that inks and glues just love to stick to. Now, you're probably thinking, okay, fire is cool, but are there other ways to do this? And yeah, there are. But flame treatment has some serious perks that make it the go-to choice, especially in the world of high-speed manufacturing. So let's put it head-to-head with the other main method, wet chemical treatments. That's where you're literally dipping parts into big vats of acids or solvents. Right off the bat, flame treatment is way, way faster. You can build it right into an assembly line. It also takes up a lot less space and usually costs less to set up. But honestly, the biggest win? You're not dealing with huge amounts of nasty chemicals and all the wastewater problems that come with them. That's a huge deal, both for the company's operations and, for the environment. But of course, when you're literally playing with fire on an industrial scale, things can get tricky. This isn't something you just wing. It's a super high-stakes engineering game where precision is absolutely everything. And this quote right here just nails it. The biggest risk is, well, it's pretty obvious, too much heat. The perfect treatment happens in the blink of an eye. We're talking milliseconds. If you go even a tiny bit too long or a little too hot, you don't get a nice, ready-to-bond surface. You get a melted, warped, totally useless piece of plastic. The line between success and failure is incredibly, incredibly thin. And it's not just about melting the whole part. Engineers have to worry about preventing hot spots, which would mean some parts of the surface stick well and others don't. Plus, you've got to think about the environmental stuff, like emissions. And of course, safety is a huge one, especially when you start using fuels like hydrogen. This is why companies pour so much effort into designing the perfect burners. They use some seriously sophisticated computer modeling. It's basically like a virtual simulator for fire to make absolutely sure that the flame is perfectly even and stable every single time. Okay, so now that we've got the science and the risks down, let's look at where you can actually see this amazing balancing act in your everyday life. And the answer is pretty much everywhere you look. Think about pretty much any car made in the last 20 years. The bumpers, the dashboard, a lot of the body panels, they're all plastics and composites. Flame treatment is what gets those surfaces ready for those beautiful, flawless paint jobs and the super strong glues that have to hold up for years through blazing summers and freezing winters. And hey, look at that. We're right back where we started with our trusty shampoo bottle.
This is it. This is the tech that makes sure the logo stays crisp and the label doesn't peel off in the shower. It's used on tons of plastic containers and packaging you see on store shelves every single day. And it's not just about looking good either. In the really high-tech world, flame treatment is used on advanced composites for structural bonding. We're talking about making sure that critical parts in things like industrial machinery or even aerospace components are bonded together with incredible strength. It's absolutely crucial for safety and reliability.
So when you boil it all down, what's the big idea here? Well, it really comes down to this incredible balancing act that engineers have to pull off day in and day out.
Look, the bottom line is this. Flame treatment is just ridiculously effective. It's fast, it's efficient, and it solves a huge problem in manufacturing. But all of that power is balanced on a razor's edge. It's this perfect marriage of raw, intense heat and incredibly precise, sophisticated engineering. So, the next time you pick up a bottle and see that perfect logo, or you admire the shiny finish on a car bumper, you'll know the secret. You'll know it's all thanks to a quick, precise touch of fire. And it really makes you wonder, right? What other invisible engineering feats are all around us, quietly making our world work?